All right, hello, Mrs. Teasley here. We're going to talk about solving polynomial and rational inequalities. I'm going to go through the lesson and show you how to solve it algebraically, by hand using paper pencil. Then I'm also going to show you how you can solve it or check it by looking at a graph. I'll open up Desmos and we'll come back and check all the solutions. So hopefully that will be helpful for you also. All right, so starting off with the first one, it just says to solve. We have a quadratic equation here we need to solve. We're going to solve by factoring. So first thing we need to do is we need to factor this equation or this quadratic. So when I factor it, all right, the way I get x squared is x and x. I'm looking for two numbers that multiply and give me positive 12. But when I add them together, I get a negative 7. So that would be negative 3. And negative 4. To solve an equation, you set both factors equal to 0. So x minus 3 equals 0 and x minus 4 equals 0. And when I solve both equations, that's going to give us the solution. So the first one, I get x equals 3. And then in the second equation, I'm going to add 4 to both sides, and x equals 4. So the solution to this is just x equals 3, 4. Those will be the two solutions for that equation. All right. So the reason why they gave us the first example is because that's going to be the first step when solving any of the polynomial inequalities. All right. You want to have everything set equal to 0, and then you want to solve by factoring. So going down to example 2, we have this inequality. All right. You want to take everything and have it set equal to 0, which is already set up nicely for us. We have x squared minus 7x plus 12 greater than or equal to 0. You want 0 by itself. So the next step is to solve the equation x squared minus 7x plus 12 equals 0. So we want to solve that. And so if you remember from the previous example, we actually already did that earlier. Like this is the same equation. So I'm not going to go through all that work anymore. I'm just going to go ahead and write down the solution. I get x equals 3 and 4. So when it comes down to these inequalities, this 3 and 4 are what we call our critical values. So that's the first step. The first step is to set everything equal to 0, solve the equation, all right, as though it's equal to 0, and the values that you find, those are called your critical values. Those are the numbers that you want to put on your number line. So I'm going to draw a number line. Remember, your number line goes from negative infinity to infinity. The only numbers that you care about on this number line that you want to put up here is 3 and 4. All right, you don't have to have 0 up here. You just want to put the 3 and the 4. Those are the only two numbers you need to put on your number line, and you want to make sure they're in the correct order. So, have my critical values here. Put them on my number line, and now we have to do something called test the intervals. So we have to test the intervals. All right. So this number line, now that I put the 3 and 4 on, it's split up into 3 different intervals. I have to figure out which intervals are a part of my solution. So we're going to do something called test the intervals. So to test the intervals, you can use any number you want to in the world other than the critical values. So I can choose any number I want to test to help me find my solution. Well, the easiest number to use would be 0. All right, so anytime, if you can, use 0 to test. The only time you wouldn't be able to use 0 is if 0 was one of your critical values. So I'm going to test using x equals 0. So I'm going to test x equals 0. Well, first of all, where is x equals 0 located? X equals 0 will be located in the interval that's less than 3. All right, so I'm going to come over here to the side, and I'm going to take the original inequality. The original inequality is x squared minus 7x plus 12 is greater than 0. So everywhere I see x, I'm going to put a 0. So 0 squared minus 7 times 0 plus 12 is greater than 0. And as you can see, now that I plugged in 0, these first two terms fall off, and the only thing I have left is 12 is greater than 0. So that's why 0 is easy, because once you know you're testing 0, if it's a polynomial, it's just going to be whatever that constant is on this left side. So now I'm down to something like this, 12 greater than 0. So then I have to ask myself, well, is 12 greater than 0? Well, the answer to that is yes. Yes, 12 is greater than 0. So this is a true statement. All right, this is true. So that means that in this interval right here above this x equals 0, I'm going to put a big fat T for true. And then what happens is, if this is true, then the next interval is going to be false. It alternates. All right, let me change it to different colors. And I'll come back and show you. But that's true. This next one is going to be false. So true, false, true. All right. So I need to make a note that once you get your first interval, then the other intervals alternate. All right. So intervals alternate between true and false. So what does this mean? This means that any number that's less than 3, if I plug it into this inequality, I'm going to get a true statement. Let's check something like it says that 4 to infinity is also true. So let's just choose a random number just to check to make sure that this is correct. So let's try something like 5. All right, so now I'm going to test x equals 5. And I'm only doing this to just prove to you that the alternating numbers work. All right, the alternating intervals work. So if I test x equals 5, that's a number that's greater than 4. So once I plug this into the inequality, I should get a true statement. So the inequality is x squared. So I'm going to put in 5 squared minus 7 times 5 plus 12. And my final answer should be greater than 0. So this is 25 minus 35 plus 12 is greater than 0. 25 minus 35 is negative 10, and negative 10 plus 12 is 2. 2 is greater than 0, so that's true. All right. So your solution to this inequality is wherever you see the letter T, T for true. So where I see the letter T, and I'm going to actually graph this also, because you're going to be asked to sketch the graph. Well, we already did the graph. This is a greater than symbol. So that means that around my numbers, I'm going to put parentheses. So I'm going to shade. Everywhere I see the letter T, that's going to be my solution. And you use parentheses to close off your shading. All right. Even this one, I'm going to shade down here. I always put parentheses around my infinities. Of course, in my math lab, you're not going to see those parentheses around infinities, but your graph, well, interval notation is a short version of your graph. So when they ask me for my solution, I'm going to write down exactly what I see up here, graph. I have a parentheses at negative infinity. The comma represents the shading. I'm shading to the number 3, and then there's my parentheses. Then I have another interval, so I'm going to put union, and it goes from 4 to positive infinity. All right, so that would be our solution. All right, example 3. Let me see, yeah. All right, just plugging up my iPad. All right, so example 3, same type of problem. The only thing is I don't have everything set equal to 0. So I'm going to rewrite this so that I have 0 on the right side. So what I need to do is I need to subtract 20 from both sides. All right, when I do that, I get x squared plus x, and I'm going to put the minus 20 behind the plus x. My less than or equal to symbol, the 20s cancel out, and then there's my 0. So that's the very first step. You want everything to be set equal to 0. So set to 0, and now that it's set to 0, I'm going to solve this equation. X squared plus x minus 20 equals 0. All right, so set to 0. And solve. So to solve this, I'm going to solve by factoring. So you have to be very comfortable with factoring. When I factor this, I get x and x. I'm looking for two numbers that multiply and give me negative 20, but when I add them together, I get a positive 1. So this would be a positive 5 times a negative 4. And to solve this, you set both parentheses equal to 0. So I'm going to solve both equations. I'm going to subtract 5 from both sides here. So I get x equals negative 5. I'm going to add 4 to both sides. And that leaves me with x equals 4. So x equals negative 5 and 4 are my critical values. These are the only two numbers I'm going to put on my number line when it comes down to graphing. So off to the side, drawing a number line. Remember, your number line goes from negative infinity to infinity. The only two numbers I want on my number line are negative 5 and 4. So I'm going to put negative 5 because it's smaller, and then 4. And then you want to test the intervals. You can just choose. You only need to choose one interval to test because it's going to alternate. So again, the easiest number to work with that I recommend using is 0. And so you can start off, I'm going to just start off here and test this. So this is what I'm going to be using to test. So I'm going to test x equals 0. X equals 0 will fall here between negative 5 and 4. So once I figure out whether it's true or false, that's why I'm going to put the true or false, all right, in that interval. So testing x equals 0. So I'm using the inequality x squared plus x minus 20 less than or equal to 0. So if I plug in 0 for both of those x, I'm going to get negative 20. So this is what you're left with. It says negative 20 is less than or equal to 0. All right, in which we know this is a true statement. Any negative number is less than 0. So since that's true, that means that any number in this interval is going to be true. I'm going to put a big old T here, big fat T. So if the true is in the middle, that means on the other side is going to be false. So true, this has to be false. So then I come back false, true. So that means this has to be false. So it alternates. The only interval where it's true is here between the negative 5 and the 4. Because the original inequality has a less than or equal to symbol, I'm going to use brackets to close off my shading. And that's my solution. My solution is between negative 5, comma, 4. All right, so number 4 would be an example that I want you to try. All right, so you can pause the video, try example 4, make sure you set everything to 0, and see if you can solve. All right, so example 4. In order for me to solve this, I want to bring the 4x and the 3 over to the left side. So first thing I need to do is subtract 4x from both sides. So I get 4x squared, and I put that minus 4x behind it. It's greater than or equal to, I still have that plus 3 or positive 3 over here. Now I want to get the 3 by itself. So I'm going to subtract 3 from both sides. And that leaves me with 4x squared minus 4x minus 3 is greater than or equal to 0. Now that I have everything set to 0, I need to solve the equation 4x squared minus 4x minus 3 equals 0. To solve this, I'm going to use the slide and divide method. So I'm going to take this 4 and slide on down across the page. So I move this 4. So you have the power to move numbers. I'm going to take this 4, slide it across the page, and move it right here beside this 3. I'm going to multiply them together. So now that I move the 4 across the page, I only have this x squared minus 4x, and then this negative 3 times 4 is negative 12. Then you factor what you have here in purple. When I factor this, x and x, all right, so this is pretty simple to factor now that I don't have the 4 in the front. I'm looking for two numbers that multiply and give me negative 12, but when I add them together, I get a negative 4. So that would be negative 6 and positive 2. Now, in the beginning, I slid the 14 across the page and I multiplied together. To undo what you did in the beginning, the opposite of multiplication is division. So now what you have to do now is that you factor this, you come back and divide both numbers in parentheses by 4. All right, and this is the equation that you're actually going to solve and set equal to 0. So at this step, I'm going to simplify the fraction. This becomes x minus 3 over 2. And this becomes x plus 1/2 equals 0. To finish it off as far as the factoring goes, the denominators you move and put right in front of the x that's in the same parentheses. So my next step would be 2x because I moved the 2 in front of the x, but then you still have that minus 3 behind it. And then here in the next parentheses, the 2 goes in front of the x. So this is 2x, and you still have the plus 1 behind it equals 0. And to do a soft check, if you do 2x times 2x, you get 4x squared. When you do negative 3 times positive 1, you get that negative 3. So that's kind of how I do like a little soft check. Your goal is to solve the equation. So since I'm solving the equation, I honestly would have just stopped here. Right, so you really don't have to go to that last step. Now, if you were asked to factor, then the correct answer will be 2x minus 3 times 2x plus 1. But you really can just stop here because it's going to be the opposite of what's in parentheses. So I already know that my answer is x equals 3 over 2, and the other one would be negative 1/2. All right, so let me just show you real quick. So let's take this first factor just so you can see what I did. I'm telling you that the answer is just positive 3 over 2. So if I just take this 2x minus 3 and set it equal to 0 and solve, add 3 to both sides, I get 2x equals 3. Divide both sides by 2. And so you get x equals 3 over 2. Right. So those are just steps that to me, they're unnecessary steps. But, I mean, if you're used to, going all the way down to the actual factor answer, then feel free to do that. But you don't have to. You can stop at that previous step. So, again, here are my critical values. Yes, they're fractions. Don't be afraid of fractions. You have a calculator, so use a calculator if you need to. But I'm still going to put them in order. All right, so on my number line, I have my negative infinity to infinity. Negative 1/2 will come first, and then my 3 over 2 comes next. Again, I'm going to test 0. All right, 0 will fall between the two numbers, x equals 0. So I go to this step here. The 4x squared minus 4x minus 3 greater than or equal to 0. So remember, if you plug in zeros, the first two terms will drop off, and so you're left with negative 3 is greater than or equal to 0. So I ask myself, is negative 3 greater than 0? Well, absolutely not. So that would be a false. So that means the interval that has 0 in it is going to be false. Any number between negative 1/2 and 3 over 2 is going to give me a false statement. And then it alternates. So if this is false, then this is true on this side, true on the other side. True, false, true. Your solution is wherever you see the letter T. The original inequality is greater than or equal to. So that means I put bracket around my shading where the numbers are located. Remember, you always put parentheses around infinities. Shade out here. Even my little arrow. Bracket at the 3 over 2. We always put parentheses around infinities. So my solution to this problem would be negative infinity to negative 1/2 bracket union bracket 3 over 2 to infinity. All right, we're going to get down here and look at some of these. We'll look at a rational inequality. So you want to factor the top and the bottom. All right, well, in this case, everything is factored nicely for us. So you want to set both factors, the top and the bottom, you want to set them equal to 0. So I will take x minus 3 and set it equal to 0. And then because x plus 4 is in my denominator, I'm going to say x plus 4 cannot equal 0. All right, so anything that's in the denominator cannot equal 0. So what that tells me is that regardless of what my original inequality symbol is, so you have this inequality symbol that's greater than or equal to. So normally I would say, well, since it's greater than or equal to, I'm going to use brackets. But since x plus 4 is in your denominator and x can't actually equal, the denominator cannot equal 0, you're going to use parentheses. All right, so you have to use parentheses for whatever answer you get here. All right, so when I solve this first one, plus 3, and I'll go back over that when we get to the solution. So I get x equals 3. And then here, subtract 4 for both sides. X cannot equal negative 4. So you want to make sure, draw your attention to that. Just make sure you know that you're going to have to use parentheses or open circles, what we used to call it, when we start putting this on our number line. All right, so draw my number line, negative infinity to infinity. I'm going to put down my two numbers. I have negative 4 and 3. Negative 4 comes first, then comes 3. You find 0. All right, so on my number line, 0 falls here. So I'm going to test x equals 0. Now I like because I don't want to forget, I'm going to highlight this negative 4. So I remember when I come back to write my final answer, there's something about that negative 4 I need to remember. And what I need to remember is that I'm going to be using parentheses. All right, so testing 0. So I'm using x minus 3 over x plus 4 is greater than or equal to 0. So in place of x, I'm putting 0. So 0 minus 3 over 0 plus 4. So you end up with just the numbers, the constants, negative 3 over positive 4. All right. Was negative 3 over 4 greater than or equal to 0? Well, negative numbers are less than 0. They're not greater than 0. So I know that this is false. So I put a big old fat F in that interval. So that's false. So since that's false, that means the other two intervals on both sides are going to be true. So I start doing my shading because this is my graph. Now, when it comes down to brackets and parentheses, remember parentheses around the infinities. Well, at the original symbol, it has greater than or equal to. Normally, I will use a bracket, but at 4, I can't use a bracket. I must use a parentheses because x cannot equal negative 4. But down here, where the 3 is, shading my arrow, parentheses. At 3, I'm going to use a bracket because the original symbol calls for a bracket. All right, so that's the tricky thing about these rational inequalities. You have to remember not to include any numbers or any critical values that are in your denominator. These are the critical values. All right, so my solution would be from negative infinity to negative 4, union, bracket 3 to infinity. All right, moving down. So this would be a good example for you to try. So try this example. This will be our last example, and then we'll come back and look at the graph. All right, so hopefully you got a chance to try this. I know it had a little bit more steps to this in the previous one, but we'll just go through it together. So you have to factor the top and the bottom. You need to factor. Even at the bottom, you need to factor. All right, so off to the side, let's factor this 2x squared minus 5x plus 3. So to factor this, I'm going to use the slide and divide method again. So this would be a great example to practice your factoring. Move the 2 across the page. I get x squared minus 5x plus 6 because this is 3 times 2. Then when I factor this, I'm looking for 2 numbers that multiply and give me 6, but add and give me negative 5. So that would be x minus 2 and x minus 3. All right, it's called slide and divide or multiply and divide. So remember in the beginning, we multiplied by 2. So now we have to come in the parentheses and divide both numbers by 2. When I do that, I get x minus 1 because 2 over 2 is 1. As far as 3 over 2 goes, I can't reduce this fraction. So I take the 2 and I put it right in front of that x. So that's 2x minus 3. And then to solve this, you just set both parentheses equal to 0. So x minus 1 equals 0. 2x minus 3 equals 0. All right, this is to get my critical values. So this is add 1 to both sides. So this is x equals 1. Add 3 to both sides here. And I get 2x equals 3. Divide both sides by 2. And I get x equals 3 over 2. So I factored and I solved. All right, this. So you want to make sure everything is set to 0 like before. So even with the, if you notice, even with the polynomials and the rational, they both should have a 0 on the right side. So I have 2 critical values. I have a 1 and I have a 3 over 2. We also have to deal with the bottom. We have to factor the bottom. The bottom is 2 minus x. So when I factor this, first of all, it's not factored because the x, you want the x to be first. So this should be negative x plus 2. So I just rewrote it in the correct position. So now to factor this, the only thing you can factor out is a negative 1. So when I factor out a negative 1, I'm left with x minus 2. And this is what you set to equal and you solve. So to solve this, the only thing you set equal to 0 is what's in this parenthesis. So x minus 2 equals 0. So you only set the x variable stuff to 0. Add 2 to both sides. So x equals 2. Because this is in the denominator, x can actually not equal 2. So this is a cannot equal to symbol. So I need to remember that. That means that regardless that the original inequality is greater than or equal to, I can't use a bracket. I have to use parentheses for this particular number. So on my number line, I need to put all 3 numbers, 1, 3 over 2, and 2. Put them in the correct order. So the first one will be 1. 3 over 2 is like 1.5, so that will come next, and then you have 2. And then you want to test 0. All right, remember, you always want to use 0 unless it's one of your critical values. So I'm going to test x equals 0. So when I test x equals 0, you go to the original inequality, 2x squared minus 5x plus 3 should be greater than or equal to 0 over 2 minus x. Wherever you see x, you're going to put in 0. So all the x stuff is going to drop off. And you're left with a 3 over 2 is greater than or equal to 0. Well, we know that 3 over 2 is bigger than 0. This is true. So if that's true, that means this statement, this interval is true. And remember, it alternates. So true, false, true, false. You're going to shade wherever you see the letter T. So here, this arrow. At 1, I'm going to use a bracket from the beginning because it says greater than or equal to. When I get between 3 over 2 and 2, I'm going to put a bracket around 3 over 2. All right, so both of these, you're going to use bracket. But for the x equals 2, you have to use a parentheses. So just remember, so I will highlight that just to remember at the end. So my answer to this, for the parentheses down here, your answer to this inequality, the solution would be negative infinity, comma, 1 with the bracket, union 3 over 2, comma, 2, parentheses. All right, so we're going to stop there. Now I'm going to go and just show you a few of these using Desmos to show you how this shows up on a graph, like how you can check your solution. So let's just look at a couple. Let's look at the first one here, example 2. So it says x squared minus 7x plus 12, and it has greater than 0. So I'm going to put this into Desmos. So you only want to put the y, you want to put y equals, don't put the inequality, so I'm going to just put y equals x squared minus 7x plus 12. So the inequality says, when is this, all right, x squared minus 7x plus 12, when is it greater than 0? When are the y values greater than 0? So let's go ahead and find our x intercepts or our critical values. So note our critical values are 4 and 3. Those are your x-intercepts. So it's asking you, when is the graph, when do you see the red line? When is the red line above the x-axis? Well, it's above the x-axis when x values are less than 3 and when x values are greater than 4. All right, so hopefully you can see that by looking at the graph. So let's just check this. So just by looking here, I see red graph when x is less than 3 and x is greater than 4. So let's see if that's what we had. Exactly. When x is less than 3. So that's what negative infinity to 3. And when x is greater than 4. So from 4 to infinity. All right, that's how you read it off the graph. Let's look at example 3. All right, so, what happened here? I don't know what happened there. See if I can delete this. All right, the solution to this, let me write it back down. The solution to this is just from negative 5 to 4. All right, so let's put this in our in decimals. X squared plus x minus 20. And this is just a nice way to just check your answer. So x squared plus x minus 20. Y equals x squared minus x. Is it minus x and no, plus x minus 20. All right, so I'm going to hit. So the inequality, so my critical values, which are your x-intercepts, negative 5 and 4. So it says, when is this y value? So here, when are the y values less than or equal to 0? So when are your y values less than 0? So when are they below the x-axis? So when you look at the graph, notice how in the graph, below the x-intercept, below the x-axis, the blue graph falls between negative 5 and 4. So what you have on paper should match up to the graph. So hopefully that's going to be useful and help you out when it comes down to checking your final answers. All right.